Hello, sixth graders. Today we're going to be starting Module 14. And so 14.1, lesson 14.1 is distance on the coordinate plane. So in your math journals, you're going to set your page up. You're actually going to use both pages, both the left and right sides. And so on the left side, you're going to set it up like this. And you'll have the title at the top, the title of the lesson, and then you'll divide it into 3 sections, and you'll want your biggest section in the middle. Okay, on the other side, on the right hand side, you just need a big space for the 4th box. In box number 1, you're just going to write some definitions. So the first one is axis, and an axis is the horizontal or vertical line that intersects at 0 on a coordinate plane. Absolute value is the distance of a number from 0 in either direction. And reflection is a point located on the opposite side of the axis at the same distance from the axis. And we'll talk about that more in a little bit. Okay, in box number 2, you're going to write this information down, so you'll want to pause your video so that you can write all of this down to start with. Once you have this all written down, then we can go ahead and start. So we're going to use absolute values to find the distance between 2 points. So in example 1, we're looking at points A and B on the coordinate plane, and A is at +4, +3. B is at +4, -2. And if you look on the coordinate plane, you can see that A and B are in different quadrants and that we're looking at a vertical distance. So because of that, we're going to use the y values when we look for absolute value and when we look for distance, because we're looking at the vertical distance, which is along the y axis here. And we're going to add because A and B are in different quadrants. So we have to, add them. So I'm going to take the absolute value of 3 plus the absolute value of -2, which becomes 3 plus 2, which gives me 5. So A and B are 5 units apart. In example 2, I've graphed the points C and D. C is at -1, -4, and D is at -5, -4. And in this case, they're in the same quadrant, so when 2 points are in the same quadrant, we have to subtract to get the distance. And I'm going to use the x value this time because I'm looking at the horizontal distance, which is the distance along the x-axis. So I'm going to use the x values, and then I'm going to subtract. So I'm going to take and I'll just start with the one that has the larger absolute value. So I'm going to take the absolute value of -5, and I'm going to subtract the absolute value of -1, and that becomes 5 minus 1, which gives me 4 units. So the distance between C and D is 4 units. Okay, in box number 3, you'll need to pause the video again and just write this information down, and then we'll do a quick example. So you're going to write down that you don't have to draw a coordinate plane every time if you know in which quadrants your points are located and you understand the math process. And this will be the case, when you move forward into higher math classes. You won't always have necessarily the coordinate plane. But of course, you can use the coordinate plane to check your work. And for now, you can draw a coordinate plane every time if you'd like. But if you wanted to figure it out without the coordinate plane, without drawing it, we would try to find the distance between A, which is at +3 and +4, and B, which is at +3, -1. So some things I need to be aware of in order to solve this without looking at a coordinate plane is I need to know that point A is in quadrant 1 because both values are positive. So it's over +3 and up +4. So point A is in quadrant 1. Point B is in quadrant 4 because X is positive. So I'm going to go to the right, and then Y is negative. So I'm going to go down. And so I end up in the 4th quadrant. So that's important to know. So because they're in different quadrants, I'm going to add their absolute values to find the distance. And then I also have to know if I'm looking at a horizontal or vertical distance. And so you have to kind of picture that in your mind. We said A was in quadrant 1 and B is in quadrant 4. And if you visualize that in your mind, you know that quadrant 1 and quadrant 4 are above and below one another. So we're looking at a vertical distance, so we're going to use the y values because we're looking at a distance between the 2 points vertically. So I'm going to take the y values, and I'm going to use absolute value. So I'm going to say the absolute value of 4, and I'm going to add because they're in different quadrants. So the absolute value of 4 plus the absolute value of -1, which becomes 4 plus 1, which gives me 5 units. So these 2 points are 5 units apart from each other vertically. In box number 4, you're going to need to pause again and write this information. This lesson just has a lot of writing and a lot of explanation in it. And you're going to write the definition for reflection. And when you think of a reflection, you have to think of like a mirror image, okay? What's staring across from you. And the math definition is that it's a point located on the opposite side of the axis at the same distance from the axis. So if we look, I think it's easier if you look at the example. So I made a coordinate, I have a coordinate plane there, and I plotted 4 points. I plotted A, B, C, and D. And you can check, where I plotted them if you want. But so to look at that, I'm going to say the reflection point across the x-axis, and remember, this is my x-axis here, for A is B, because I'm looking at, what is across from each other, the same distance from the x axis. So A and B are across from each other across the x-axis from each other, and they're both 2 points or 2 units away. So A and B are reflections of one another, and they're both 2 units away from the x-axis, like I said. If I look at the reflection point across the y-axis, and I'll change my color for that. Okay, here's my y-axis, and I want to know the reflection point for A. I'm going to go across the y-axis, and I have to look and see A is 3 points away from the y-axis. So the point that is 3 points away in the reflection is point C. And so the reflection point across the y-axis for A is C, because they're both 3 units away from the y-axis. Okay? And they're directly across from each other. So practicing that, the reflection point across the x-axis, which remember is the red again, okay, that's my x-axis. And so the reflection point across the x-axis for point C is going to be D, because that's across the x-axis. And it's hard to kind of write that in, which is at -3, -2, but it's hard for me to write that in with my stylus. And then both points are 2 units from the x-axis. So basically, 2 units from 0. And then the reflection point across the y-axis for C, and remember now we're looking again at the green, because we're looking at the y-axis. So the reflection point across the y-axis for C is A. And actually we kind of already did that, but I think you get the point. And both are 3 units from the y-axis. So the distance is 3 units from the y-axis. Okay, and that was kind of the same as up in the example, but we just did it the other way. We could do, though, the same thing with D and B. We could say that the reflection point for D is B on the y-axis, and that they are both 3 units away from the y-axis. When you're finished, this should be what the left side of your paper looks like, or pretty close to it, when you're looking at distance on the coordinate plane. And this should be on the right hand side in your journal, what box number 4 or section 4 should look like. And so that's it. We've covered how to find the reflection and how to find distance on a coordinate plane. Good job, you guys.